In this section, we're gonna start talking about client-side attacks. So, most of the time, it's better to try to gain access to your target using the server-side attacks. So, try to find exploits in the operating system and in the applications installed. If you tried that and it didn't work, or if your target is hidden behind an IP, so if the target person is not in the same server as us, on the same network as us, and if the target person is using a network, so if you ping their IP, you won't be able to reach it because they're hidden behind the router or behind a network, then your next resort is going to be the client-side attacks. So these attacks require the user to do something. So the user is going to have to open a link, they're going to have to install an update, they're going to have to install a picture or open a picture, or they have to interact, they have to do something. And once they do it, we will be able to run code and achieve our goal. Therefore, because it requires user interaction, information gathering is very important in this case, and we don't only need to get information about the installed applications, we also need to know the person. We need to know their friends, we need to know the networks they use, the websites they use, if there's any websites that they frequently use and trust. Therefore, the information gathering section in here is going to be focused on the person rather than focused on the applications and on the operating system. In this lecture and the next few lectures, I'm going to teach you how to create your own backdoors. As an ethical hacker, it is very important to understand and learn how to do this properly, because you will find yourself in so many situations where you have to generate backdoors to gain full control over the target computer. So first of all, what do we mean by a backdoor? A backdoor is simply a program that gives us remote control over the system that it gets executed on. So it allows us to remotely execute system commands, access resources such as the storage, upload and download files and read them on the target system, see what they type on their keyboard, access their webcam, even access their desktop, and so much more. Basically, you'll be able to remotely do anything that a normal person can do on their computer once they execute your backdoor. So a backdoor is simply a program. It's simply an executable. But what makes it special is part of its code that we refer to as a payload. So the payload is the part of the code inside the backdoor, inside the executable, that allows us to remotely control that computer, execute system commands, access its resources, and so on. So the program that we're going to use to generate payloads is called MSF Venom, and I'm choosing to go with this program because it's kind of the industry standard to learn how to use MSF Venom. And then there is more advanced tools that modify the payloads generated by MSF Venom and make them bypass antivirus programs and do fancy stuff with it to allow you to bypass security and so on. But as an ethical hacker, and especially in this course, it is very important to learn how to use MSF Venom first before moving on to more advanced techniques, which I cover in my other courses, such as the social engineering course and the cloud course, where I show you how to use proper C2 frameworks to control the computers that you hacked from within the cloud. But before we can do that, it is very important to have a strong foundation in this topic, and that's why we're starting with MSF Venom. So if we actually just go ahead to Kali and type MSF Venom, followed by --list to list all of the payloads that we can use. So like I said, MSF Venom is the program that we're going to use to generate our backdoors, and we're simply asking it to list all of the payloads that it has. And if I hit enter and give it a few seconds, because you'll see we're going to get a huge list of payloads. As you can see, there are so many payloads to pick from. And as you can see, the first part is the name of the payload, and the second part in here is a description of how this payload works. And obviously you can Google the name of the payload to learn more about it. But before we do all of that, I want to spend this lecture to explain to you the naming pattern that we have in here. Because as you can see, most of these payloads are made up of 3 parts, as you can see in here, separated by forward slashes. Now these parts, first of all, refer to the platform that the payload works on, the type of payload, and the communication channel or method that the payload is going to use in order to give you remote control over that computer. So an example would be Windows shell reverse HTTP. And as I said, the first part in here is the platform. So this specific payload is designed to work on Windows computers. Now, MSF Venom, as you saw earlier, has so many different payloads. So you've got Linux payloads, OS X, Apple iOS for iPads and iPhones. You've got Android payloads. The platform can also be a programming language, such as Python or Java. So payloads that start with Python or Java mean that they will work on any computer that is able to run Python code or Java, regardless of the operating system. It doesn't matter if it runs Windows, Linux, or Apple OS X. If you create a Python payload, it will work on any computer that has a Python interpreter, regardless of its operating system. And then we even have generic payloads that are designed without thinking about the operating system. They're designed to work in different scenarios and different operating system, regardless of that operating system. So that's the first part of the payload, the platform. Now the next part is the type of the payload. And in this example, it's shell. And what that means is that it's going to give you remote shell control, so you'll be able to do anything that you can do on that computer using its shell, using commands. Now again, there are so many other types than shell payloads. We have Meterpreter payloads, which are payloads specifically designed by the Metasploit team. They run in memory, they use encrypted communication, and they are designed to be modular and extendable, so they offer so many features. And these are actually the kind of payloads that we're going to use ourselves later on. You also have payloads designed to inject their code into other files, such as the DLL inject that injects itself into DLL files, and the PE that is designed to be injected into portable executable files. You got the VNC inject payloads that allow you to access the desktop of the computer that you've hacked. You even have very simple payloads that simply display a message box. And you might think that this is not useful, but it actually is. If you're just testing and trying to test an exploit, not a backdoor, you don't really want to hack the target computer. You just want to see if your exploit worked, because you're running the code yourself. So a lot of the time you want to keep things simple, and you want to go with a very simple payload that will simply display a message box. And if you see the message box, it means that you actually managed to exploit whatever vulnerability that you're trying to exploit. So the first part is the platform, and the second part is the type, and the third part of the payload name is the communication method or channel, like we said. And if you look closely, you can see that even this part is almost made out of two parts. So the first part is the direction of the connection, and I'll explain that to you in a second. And the second part is the protocol used in this connection. So when it comes to the direction, the most common types are going to be either bind or reverse. And let me explain to you what I mean by that. Let's say that you have two computers. This is you, the hacker, and this is the target computer. In a bind or a direct connection, when the backdoor is executed on the target computer, it opens up what we call a port. So you can think of this as if it's a socket on the wall. And then, as a hacker, you would go in whenever you want and connect to the socket using your plug. Now, the problem with this is opening a port in here at the target computer could potentially raise a lot of alarms. So if they have a firewall installed, it'll raise an alarm, and even when you connect to it, the connection is not a typical connection that a normal personal computer would do. However, if we go with a reverse connection, we do the reverse. So instead of opening a port at the target computer, we actually open a port in our own computer. Therefore, even if our firewall complains about this, we can disable the firewall because we are doing this ourselves and we know what we are doing. And then when we execute the backdoor at the target computer, the backdoor is going to connect from the target computer to our computer. So this connection is much less suspicious because, first of all, we're not opening any ports at the target computer, and connecting from the target computer to any other destination is very normal, because even if a target goes ahead and loads a normal website, they are basically connecting to that website on port 80 or 8080. And this is exactly what we can do. We can actually open port 80 or 8080 so that this connection looks less suspicious, and even use a protocol that is used by web servers so that our connection seems like normal web traffic. So remember, we said the second part of the communication is a protocol. So when you load a website, you either load it over HTTP or HTTPS. So we can actually use a reverse connection on a port that websites use, which is port 80 or 8080, and set the protocol to HTTP or HTTPS. And that way, the connection is going to seem very similar to a connection that a computer would make when they load a website, thus allowing us to bypass many firewalls and security measurements. So this is a very common naming convention when it comes to payloads. We have the platform in the first part, the type of the payload in the second part, and the communication method in the last part. So let's just have a quick look at a few examples just to make sure that we understand this properly. So these are very common payloads that you might see or use yourself in many places. As you can see, the first three in here will only run on Windows as the platform. You can see the type in this one is shell, Meterpreter, and Meterpreter, and we explained what these are. And both of these are using reverse connection. This one is using the TCP protocol. This one is using the HTTP protocol, and this one is actually using a bind or a direct connection over the TCP protocol. Now, as mentioned earlier, there are payloads that would work on any computer as long as they have a specific programming language installed. So we have an example of a Python payload in here. So the platform here is Python. It's not an operating system because it will run on any operating system that has Python installed. Now, I also wanted to point out these two payloads in here, and as you can see, they don't follow the exact naming convention that we spoke about. You will see outliers in the payloads in there because not all payloads can actually be used as backdoors, and you'll see that as you go through this course and maybe my other courses. But these payloads can actually be used as backdoors. But you can see in this one, the first two parts are actually referring to the platform. So it's an Apple OS X x64, not the ARM computers. And then the next part is actually the type, so it's not really separated with a /. And then the last part is the communication method in here. Same with this Apple payload. So this is for Apple iOS and it's for ARM chips. So this one is for x64 chips, this one is for ARM chips. Again, the first two parts are referring to the platform, and then the next part is referring to the type, and the final part is referring to the communication. So sometimes the /s could be a little bit misleading, but the order is always the same. The first part of the payload indicates the platform, the second part indicates the type of the payload, and the last part is the communication method. Now, we're actually going to probably be using only one or two types of payloads throughout the course, but like I said, this course is designed to teach you the basics of hacking, and it is very important to learn how to create your own backdoors and payloads using MSF Venom, and to do that, it's very important to understand the naming convention that the payloads use. And in the next lecture, I'm going to show you how to put this in practice, create a backdoor, and use it to hack a Windows computer. Now that we understand what we mean by a backdoor, a payload, the naming convention, and so on, in this lecture we're going to use all of this knowledge in order to create a backdoor that can be used to remotely hack and control Windows computers. So as mentioned previously, the tool that we're going to be using is called MSF Venom, and it's always a good idea to do --help the first time that you use a tool in order to see all of the options and arguments that you can use with it. So as you can see, this gives us a list of everything that we can do, and straight away we can see the first option is the -L or --list option, which is what we used previously to list all of the payloads available in this tool. So I'm actually gonna split the screen and we're just gonna run it quickly. We're gonna do MSF Venom --list payloads in order to get a list of all of the payloads that we can use. And we saw previously that we got a really big list of payloads. So once you find a payload that you like and that you'd want to use, we can go ahead, and if we look at the help menu in here, you'll see that we can select the payload using the -P or --payload option. So I'm going to go ahead and do MSF Venom again, and I'm going to do --payload to select the payload that I want to use inside of my backdoor. And the payload that I'm going to want to use is a Windows payload. So the platform is Windows and the type is interpreter payload. So this is the type of payloads that I said in the previous lecture that is specifically designed by the Metasploit team. It runs in memory, it encrypts its communication between the backdoor and the target, and it has so many modules and so many options, and you're going to see how useful it is as we go through the course. And finally, as we know, the last part is the communication method. So we're going to use a reverse payload because, as mentioned in the previous lecture, reverse payloads connect from the target computer to us, allowing us to bypass firewalls and many security measurements. And the last part, we're going to set it to use the HTTPS protocol again, so that the traffic looks less suspicious and looks similar to a normal traffic that the target would create when they load normal websites over HTTPS. So now that we selected the payload, we can actually do --list options to see the options that we can set for this payload, so we can instruct it how it should work. So we're gonna go ahead in here and do --list options. We're gonna hit enter. And as you can see, we get a big list of all the potential options that we can use, along with the description of this option. Now, these are all the advanced options, so we're not actually going to be setting any of these. They're not mandatory at all. What we're interested in is the basic options that we have in here. So as you can see, these options are required, and we can also see the description of these options. So the lhost specifies the local listener hostname. So that basically means the IP of the computer that you want to receive the connection on. So this is this computer, our hacker computer. And the L port is the port that we want to listen on. It's this part of the diagram. It's the plug in the wall. So it's the port that the target machine will connect to once the backdoor is executed. So first we're going to set the lhost. So we're going to go back to our command and we're going to remove the --list options because we don't want to see the options anymore, but we actually want to set the lhost value, which is going to be the IP of this current computer because I want to receive connections on this computer. So I'm going to split the screen in here and I'm simply going to run ifconfig to get the IP of my current computer. And as you can see, this is the IP of this computer right now. You might have a different IP. That's completely normal. Just make sure you use the correct IP. So it's 192.168.0.26. Next, we're going to set the next required option. So if we scroll up, that is the L port. And like I said, this is the port that we're going to receive the connection on. So we're going to follow the same syntax. We're going to type L port, which is the name of the option that we want to set, equal to the value that we want. And the value that we want is going to be 8080. So I'm choosing the 8080 port because that is a common port that is used by web servers, port 80 and 8080. And this makes perfect sense because we are using a backdoor that's going to use HTTPS, which is a protocol that is usually used by web servers to serve websites over HTTPS, and the port that we're using is 8080. So when this backdoor gets executed on the target computer, it's going to connect to us on port 8080. And it's going to use the HTTPS protocol to do that. And this is great because the target computer will do that every time it loads a website that uses HTTPS, which is pretty much all websites these days. That's why the traffic is going to look very similar to traffic that is generated when the target computer loads normal websites. So now that we have the basic options set, the last thing that we need to do is actually export this into an actual file. And to do that, you can see here in the help menu, we can use the -F to specify the format of the payload. So we're going to do --format, and that's going to be an executable. So we're doing exe. And finally, we can use the -O or --out to specify the file name. So we're going to do --out followed by the file name that we want, and I'm going to call it rev https 8080.exe. And I'm just using a meaningful name here just so that I know this is a reverse HTTPS backdoor that uses the 8080 port. And that's it. Our command is done and it's ready to be used to generate a backdoor. But let's go through it one more time before we hit enter. So we're using MSF Venom, which is the tool that we're using to generate the backdoor. We're using the -- payload argument to specify the payload. And this is the payload that we are choosing. So it runs on Windows platforms. The type of payload is a Meterpreter payload, and it uses reverse connection over the HTTPS protocol. Then we're setting the basic options of this payload. So the first option is the lhost, which is the IP of the computer that will receive the connection from the target computer. And I put my current IP. And then we specified the port that we want to receive the connection on, and we set that to 8080. We're using the -- format argument to specify the format of the backdoor, and we want it to be an executable. And then we're using the -- out argument to specify the output file name of the backdoor, which is going to be called rev https 8080.exe. If we hit enter, this will take some time and it will generate the backdoor for us in the current working directory. So as you know, if you want to get the current working directory, you can use the pwd command, and you can see that I am currently in root. So if I go to my file manager, it will load the root directory by default. And if we look down, you'll see that we have my backdoor generated in here. So next, I'm going to show you how to use this backdoor in order to hack a Windows computer and gain full remote control over it. Now that we created a backdoor that when executed on a target computer, it will send a reverse connection to our computer. Before we do that and before we go ahead and execute it, we need to go ahead and listen for incoming connections. So we need to create this socket, if you may, so that when the backdoor is executed on the target computer, it can actually go ahead and connect to the port or to the socket that we have open. So in this lecture, I'm going to show you how to open up a port and listen for incoming connections on our current computer so that when the backdoor is executed on the target computer, it will send that connection back to our computer. To do that, we're actually going to use Metasploit. So first of all, we need to launch the console by doing MSF console, as you know. Give it a moment to boot, and when it starts, we're going to use a module that is called Exploit Multi Handler. So basically, this is a module that is designed to help you open up a port in your computer so that you can receive connections from computers that you hack. So we're going to hit enter to load this module, and because we don't know how to use this module, we can simply do show options to see all of the options that we can set for it. And as you can see, you get a nice message showing you the module name, showing you the payload that this module is using by default, and its options. Now, if you look at this payload, you'll notice that this is not the payload that we used in our backdoor, and that's why we're going to have to modify this. And you can modify this value exactly the same way you modify any value in Metasploit. So we're going to do set, followed by the option name that we want to modify, which is the payload. The main thing you want to make sure is that you use the exact same payload that you used in the backdoor. So in the backdoor, we used Windows, Meterpreter, reverse HTTPS. If we do show options again, you'll see that we're actually going to see different options because the payload is different. So you can see that the options here are again very similar to the options that we set when we created the backdoor. So the main two options that we need to modify are the lhost and the lport. And the lhost is the IP of the computer that will receive the connection. And in our case, it's this computer right here. And the lport is the port that you want to receive the connection on. And again, both of these values need to match the exact same values that you set in the backdoor. So to get our current IP, we saw that when we ran the backdoor, we can do if config, and we can see my IP is right here. So I'm going to copy it. And again, we're going to set its value exactly the same way that you set values in Metasploit. So you do set, followed by the option name, which is lhost, followed by the value. And I'm going to paste my value, which is my IP. Next, we're gonna set the port. So we're gonna do set option name L port, and the port that we used in the backdoor was 8080. Now that we set everything, we can do show options one more time to make sure that the options were set correctly. And perfect. As you can see, we can see that the L host is set to my IP, which is the same value that I used in the backdoor, and same goes for the L port. So now that we're happy with everything, we can do exploit. And this will basically just sit. It'll literally just open up the socket, open up this port 8080, and it's gonna wait for incoming connections from any computer that executes the backdoor. So in the next lecture, we're gonna go ahead, execute the backdoor on a Windows computer and see if we're actually gonna be able to get a reverse connection and be able to remotely control that computer. So now that we are listening for incoming connections on our hacker machine, we are ready to go ahead and execute the backdoor at the target machine and receive a reverse connection from it and remotely control that computer. So first of all, we're gonna have to transfer the backdoor to the target machine. In the next lectures, I'm gonna cover smart methods of delivering backdoors and malware to the target computers. But for now, just because we're testing, I'm trying to keep everything as simple as possible. And we just want to make sure that the backdoor that we created works. That's why we're gonna use the web server that is built in within Kali Linux to upload the backdoor and download it from the target computer in here. So first of all, I'm gonna go ahead and copy the backdoor to the location that the web server uses to serve files. So as you saw previously, the backdoor was placed in my home directory. So I'm simply going to copy it. And then I'm gonna click the title bar in here, or you can do Control L in order to open the path bar, as you can see in here, and then type the location that you want to go to. And we wanna go to var www.html. Again, this is the default location that the web server uses to serve files. So in here, I'm going to create a new directory or a new folder, and I'm going to call it evil files. And I'm going to use this in the future as well to store my evil files so that I can easily share them with testing computers and test these evil files, because it's very important to make sure that your malware or backdoor or keylogger is working properly before you go ahead and use it in the wild. So now that I'm here, I'm simply going to right click and paste in order to paste my backdoor. And we have it in here now. And next, we're going to go ahead and start this web server. So I'm going to clear my screen. And to start the built-in web server in Kali, we're simply going to do service Apache 2 start. So we're basically saying we want to start a service that is called Apache 2. And Apache 2 is the name of the built-in web server in Kali. I'm going to hit enter, and if you don't see any error messages, it means that the web server is running properly. So to access this web server, all you're going to need is the IP of the Kali machine. And we can get the IP of the Kali machine, as you know, by doing ifconfig. And it's the same IP that we used in the backdoor as well, which is 192.168.0.26. So I'm going to go to the target Windows computer right here, and I'm going to open up my web browser. And I'm simply going to navigate to the IP 192.168.0.26. And if you load it as is, you're going to get the default welcome screen of the web server, but our file is stored in a directory that is called evil files. So I'm going to do /evil-files to load the evil files directory. And as you can see in here, we have the backdoor that I generated. And like I said, this is not a very smart method of delivering backdoors, but we are just testing at the moment, and we just want to make sure that the backdoor works. And before we download this backdoor, I'm going to go ahead and disable the security on Windows. This is important because we didn't implement any techniques to bypass antivirus programs or Windows Defender in this backdoor, because at the moment we're focusing on building a very simple backdoor. It is very important to break the big problem into simple problems. First, learn how to create a backdoor, make sure it's working properly, and only then you can go ahead and build up on this knowledge and try to make that backdoor bypass antivirus programs and so on. So at the moment, we just want to make sure that we can create a basic backdoor that actually allows us to remotely control the computers that it gets executed on. So before downloading this, we're going to go ahead and disable Windows Defender. So we're simply going to go to the Start menu. We're going to look for Security. We have it right here. And we're going to click on the Virus and Threat Protection. We're going to click on Manage Settings. And you want to make sure that everything is set to off in here, as you can see. Otherwise, the backdoor will be detected and it'll simply not work. So we're going to click it in here in order to download it, and that's downloaded for me. And we can see it here in our downloads directory. And also, as you can see, this file does look a bit scary. It's simply an executable. We will cover how to make this look and function like any other file, like an image or a PDF or anything else. Again, we're breaking the big problem into simpler problems, and we're focusing on a very simple goal, which is to get a backdoor working on Windows. So right now, just for testing, we're going to double click this file to run it, and we're simply going to say run anyway, and then we're going to go to the Kali machine. And perfect, as you can see at the window where we started our multi-handler, you can see that we received a connection back. And the prompt now says Meterpreter instead of MSF, which means that we actually received a connection back from the Windows computer through the Meterpreter payload that we created. So just quickly, we can do sysinfo to get information about the system that we just hacked. And as you can see, we can get the computer name, the operating system, the architecture. So now we can go ahead and execute any command that the Meterpreter allows us to execute. And you can do help to get a full list of all of these commands. But don't worry about this now. We will cover this in details in the post-exploitation section later on. But for now, we've basically managed to hack this computer and gain full remote control over it. So right now we can do anything that the actual user of this computer can do on their computer, but we can do it remotely from within our Meterpreter session in here. Now that you know how to create your own backdoor and use it to hack a computer and remotely control it, in this lecture, let's talk about how to get this backdoor to bypass antivirus and security programs. So first of all, in order to do that, we have to understand how these antivirus programs work. And there are two main principles that these antivirus programs work on. The first one is known as static analysis. And as the name suggests, in this approach, the antivirus program compares the code of the executable or the backdoor to a database of known malware. So for example, let's say you have your executable backdoor in here and you send it to a target computer and they download it, and that computer has an antivirus program. The program is going to go ahead and compare the code in this executable to a database of known malware and known threats. And if it manages to find code in this database of known threats that looks similar to the code that is inside your executable, then it's going to know that this executable is harmful. Otherwise, it will not detect this executable. Therefore, since this technique is static and it only depends on the code that exists in the actual program, we can bypass this technique by simply making the program more unique, so that the code used in our program does not match any code that exists in this database of known malware. And you can do this either manually. If you know programming, you can write your own backdoor or modify the existing code of the backdoor, or you can use ready tools such as packers, encoders, or obfuscators. All of these tools basically modify the code of the program so that hopefully the resulting code is unique enough to not match anything that exists in this database of known malware. So this first approach is actually easy enough to bypass, but it gets trickier when antivirus programs get smarter. and employ a technique that is known as dynamic or heuristic analysis. This technique analyzes the behavior of the executable or the backdoor and decides whether it is harmful or not based on that. So instead of simply comparing its code to a database of known malware, in this example, let's say you have your backdoor in here and it gets downloaded on a target computer. The antivirus program in this target computer will execute your backdoor in a sandbox or in a controlled environment so that it can't actually exit this sandbox. And then it analyzes the behavior of this executable. If this executable is trying to connect to another computer, as we saw earlier, that means it's a backdoor, or if it's trying to modify registry entries, or if it is encrypting certain paths in the computer, then we know that this is a ransomware. So based on the behavior of the executable, the antivirus program is going to decide whether this executable is harmful or not. So in this case, simply making the code more unique is not enough, because even if you have unique code that is doing suspicious stuff on the computer, the antivirus program is going to flag it as a virus or as malware. Therefore, in order to bypass this technique, we're going to have to make the program seem like it is not harmful. And to do that, you're going to have to be a little bit creative. For example, you can add benign or safe operations, so you can make your malware or backdoor seem like it's a legit application. So for example, just to keep it simple, you can have code for a calculator program in there and at the same time have your backdoor executed at a certain stage. You can also delay the payload execution. So there are a number of ways of doing this. For example, you can detect whether this backdoor is being executed in a sandbox or a virtual environment. And if it is, then don't execute the payload. Only show the calculator code, for example. You can also simply wait for the user to do something. So you can wait for a certain amount of time, or you can wait for the user to run a certain application or do a certain action and only then execute the payload. We can also get a bit creative with how we communicate with the backdoor. So instead of making a direct or a reverse connection, we can actually facilitate the communication between us and the target through programs that are known to be safe. So we can facilitate the communication through known platforms like GitHub, Telegram, and Discord. And I actually cover all of that in my course that shows how to use the cloud for hacking. Now, as you can see, bypassing antivirus programs is a really big topic and it can take up so much of this course. But this is a basic course that is designed to cover the basics of hacking. So if you want to learn more about this, as you can see, there are two main approaches. Either you're going to rely on tools such as packers, encoders, obfuscators, or even the tools that I mentioned that will facilitate the connection using unconventional methods like Discord and Signal. All of that is covered in my social engineering course and in hacking using the cloud course. The other approach would be to manually implement these techniques, so manually make the program more unique and manually add more operations and make the program seem safe. And you can do that manually if you know programming. And I covered that in my Python course, in the course that I teach Python and ethical hacking from scratch. All of these courses, along with more information about them and special discounts for you guys, are all included in the last lecture of the course, the bonus lecture. So check it out if you're interested in learning more about this. And I'm also going to include some links and videos in the resources of this lecture just to show you these methods in action and how useful they can be to bypass antivirus programs.